Hello everyone, this is Mr. Kaviani, and by the end of this series of videos, you should be able to explain the definition of energy and identify relevant forms of energy, as well as quantify the kinetic and gravitational potential energies of various objects. While there are many different forms of energy, there are specific forms of energy that we will delve into in greater depth in AP Physics 1. The first of these forms of energy is kinetic energy, the energy associated with the motion of objects. For example, this is the kind of energy that an Olympic sprinter would have traveling at high speeds. The second form of energy that we will discuss in this class is gravitational potential energy, the energy stored in the gravitational field between an object and the Earth that it possesses due to its height above the Earth. So for example, this is the kind of energy that someone jumping out of an airplane skydiving would have. And as they fall to the ground, that energy would take different forms, and that's what we'll discuss in a little bit, is about how energy of one form can become energy of another form. The third form of energy that we will discuss in greater depth later in the course is what we call elastic or spring potential energy. This is the energy stored in an elastic object, like a bowstring, or a spring, due to it being stretched or squished in some way. So this would be the kind of energy that is stored in a bowstring, for example, when an archer pulls back an arrow and stretches that bowstring out. Now, this is also called a type of potential energy, just like gravitational potential energy, because it has the potential to turn into another form of energy, and that's what we'll discuss in much greater detail in a later video. Now, the last form of energy that we'll discuss in this class can be called thermal energy. Thermal energy in this class is going to refer to the type of energy produced when objects rub against each other or an object falls through the air if we consider air resistance. But essentially, it can be thought of as another form of kinetic energy, just of molecules at the smallest scale. Essentially, when a car brakes, for example, the road is rubbing up against that tire, and frictional force will generate heat, and that heat is really just the movement of atoms at the smallest scale. And so thermal energy can be considered a form of kinetic energy, but there are other forms as well. We can consider sound and light other forms of energy that are lost or are transferred away from an object when there's some type of frictional interaction. So we'll dive into this again in a later video in more depth as well. And together, these make up the primary forms of energy that we will discuss in this class. Now, before we go into more depth about each of those different forms of energy, it's important to discuss how energy is measured in the first place. To describe how much energy something has, we use the unit of the joule. Now, the joule happens to be an incredibly important unit in science, and on the right-hand side of the slide, you can see that the joule is actually defined in terms of many other units in science. And so, at its most basic level, a joule is defined as a kilogram times a meter squared divided by a second squared. And so, it's important to note here that in order to get an answer, if you calculate an energy in joules, you need to be using kilograms, meters, and seconds. Again, those are the respective base SI units for mass, right? Meter would be a distance, and seconds would be a measurement of time. And so you should be using those units if you are to report your final answer in terms of a joule. Later, we'll see, and if you take more physics classes, you'll see that a joule happens to also be defined in terms of newtons and pascals and watts and coulombs and volts and all different units in science. So the joule is an incredibly important quantity. It's also worth mentioning at this point that energy, unlike many of the quantities we've discussed previously in this class, is a scalar quantity. Recall that a scalar is a quantity without a direction. So it doesn't make sense to report energies with directions anyways. We can't say that something has 30 joules of kinetic energy north, right? That would be kind of strange. So energy is a scalar quantity and therefore has no direction. Just to put the joule into context for you, I've included a chart below showing you relative amounts of energy and what they're used for. So for example, a calorie, right, is around here at 4.184 joules. So if you have ever wondered how much energy is in a calorie, it's about 4 joules of energy. We can see as we go up this chart, right, there are larger amounts of energy being used. For example, family house, annual energy consumption, that's up here at about 10 to the power of 12 joules for a year, right, for a family house. A small village in India might be somewhere between 10 to the power of 12 and 10 to the power of 15. New York City area, right, annual energy, now we're talking about 10 to the power of 18 joules. World energy consumption in 1990, so quite a few years ago, 10 to the power of 21 joules. So hopefully that puts into perspective for you how much energy 1 joule actually is, or in this case, how little energy it seems to be. For that reason, you probably most often see joules referenced in terms of kilojoules or K little k capital J. That's 1,000 joules, and that's a more common unit for reporting energies just because a joule is so small. Okay, now that we know how to measure and communicate a quantity of energy, let's take a look at kinetic and potential energy in more detail.